Hello guys, we have a question here that says an infinitely long straight wire carrying current I. This is our infinitely long straight wire which is carrying current I, okay? And one-sided open rectangular loop at and a conductor C with a sliding connector located in the same plane. This is our one-sided open rectangular loop and this is our conductor C. All of these are located in the same plane and this is our sliding connector which has length L and resistance R, okay? So it slides to the right with a velocity v. It is sliding to the right with a velocity v, and the resistance of conductor and self-inductance of the loop are negligible. So the resistance and of the conductor and the self-inductance of the loop are negligible. We can neglect it. So we have to find the induced current in the loop as a function of separation R between the connector and the straight wire. Okay. So let's move on to the solution. As you can see, we close the loop. Okay. So what is the formula of magnetic field? B equals to mu naught I 2 pi r. We take the capital I because the current is infinite. The current is infinite. Okay. So because the magnetic field is going to be on the plane, so an EMF induced in it and the value of is BVL. So from this, from equals to BVL, we get mu naught I 2 pi r multiplied by V dot L. Okay, so after simplifying it, we get mu naught I VL divided by 2 pi R. So the induced current is I equals to E by R, and that is this. I equals to E by R equals to mu naught I VL by 2 pi small r capital R. Thank you.